Today's lecture is also about ANOVA, which is analysis of variance. And in a previous lecture, we discussed that why do we use ANOVA, why do we prefer ANOVA over t-test for the comparison of more than two groups, what are the problems associated with the multiple testing, especially the problems related to the type 1 error and type 2 error. And then we discussed the types of variables in ANOVA, that what is meant by the predictor or the independent variable or the nominal variable, and what is meant by the response variable or the measurement variable. And we also discussed the differences between one-way ANOVA, two-way ANOVA, and n-way ANOVA. So ANOVA, or the analysis of variance, was developed and introduced by Sir Ronald A. Fisher in 1925. And this is the test in which variances are analyzed for the comparison of mean values of more than two groups. And these are the requirements of ANOVA that we discussed in the previous lecture, that the observations, they should have a near normal distribution, there should be homogeneity of variances between different samples, and the response variable should be continuous variable, which is measured on interval or ratio scale. So the question is that how is the analysis of variance used to investigate differences between means? That we are talking about ANOVA. ANOVA means analysis of variance, and we are saying that this analysis of variance is used for the comparison of mean values. So how is this done? That how is the analysis of variance used to investigate differences between means? So this is quite a logical question. So we will try to answer this question by taking an example of three samples, and we are going to compare the individual variances with overall variance when all observations are aggregated. So let's say we have these three samples, and then we are going to take their overall variances as well. So let's see. These are the observations in the three samples, and you can see that there are 5 observations in each of these 3 samples, and their sum of observations, summation x, their mean values, and the variances are given. So what do you see from this table? That means of sample number 1 and 2 are almost similar, right? The mean of sample number 1 is 12 and the mean of sample number 2 is 13, so they are almost similar. While the mean of sample number 3 is much lower, and it is different from the mean of sample number 1 and sample number 2, right? And if we look at variances, the variances of all 3 samples are same, right? So variance of each of these samples is 10. So these are the samples in which the mean values are different and the variances are similar. So this is our example of the 3 samples, and as we saw that their individual means are different and their individual variances are same, right? So this is the table in which all of the 3 samples, they are documented, or they're listed independently or individually. Now let's see their overall values, or the values of aggregated observations, that when we aggregate these 3 samples into a single column, then what is the situation in that case? So this is the column that we have for the overall or the aggregated observations. So in this case, all of the 15 observations, they are listed into a single column. And then their summation x values, their mean values, and variances are calculated. So let's start from the value of mean for the overall comparison. So remember the formula for the mean value. This is summation x divided by n. So summation x in case of overall column is 160, and the number of observations is 15. So 160 divided by 15, we have the answer, which is 10.67, right? So this is the answer. This is the mean value of the overall observations when the observations are aggregated. Now we see that this overall mean is the intermediate of the individual means. So individual means of the samples are 12, 13, and 7. So this 10.67, which is the mean of the overall observations, this seems to be an intermediate, right? Intermediate of the individual mean values of the 3 samples. We can confirm that by taking the grand mean of the 3 individual means. So 12 plus 13 plus 7 divided by 3, we have the same value, which is 10.67, right? So this confirms that our overall mean is the intermediate of the mean value of the 3 samples. Now let's see what is the situation in case of variances. So when we calculate the variance for the overall observations, so we are, remember the formula for the variance. This is sum of squares divided by the degree of freedom. So this is sum of squares for all the 15 observations, and this is divided by degree of freedom. So the first observation is 8 and the mean value is 10.67. So the deviation of this value is 8 minus 10.67. We take the square of this value. Then the next value is 10. So 10 minus 10.67, we take the square, and we take square of all the individual observations. And the last of these observations is 11. So 11 minus 10.67, we take the square. Now we take the sum of all these individual deviations from the mean values, and that is our sum of squares, and we divide it by the degree of freedom, which is 15 minus 1 in this case, and the answer is 16. So 16 is the value of variance in this case. Now let's see if this value of 16, if this value of variance, like the mean value, is it the intermediate of the sample variances? We see that the overall variance is not an intermediate value, because the individual values of the variances for the 3 samples are 10 each. But in this case, the overall variance is 16, and we can confirm that by taking the grand variance or the intermediate variance. So this is 10 plus 10 plus 10 divided by 3, and the answer is 10. And the overall variance that we have calculated from this column is 16, which is not an intermediate value. So now the question is that where is this difference coming from? Because the mean values are same, but mean values are different, variances are same, but the overall variance is different, and this overall variance is not an intermediate. The overall mean is an intermediate of the individual means, but the overall variance is not an intermediate of the individual variances. So where is this difference coming from? To answer this question, we have to understand the concept of probability when we are taking 2 or more than 2 samples. So samples, they give rise to 2 sources of variability. Variability within a sample, which is the variability around each mean of the sample values, and variability between the samples due to differences between the means of the populations, right? So this is the variability which is found between samples. So we have 2 sources of variability: the variability which is found within a sample and the variability which is found between the samples, right? So total variability is the sum of variability between and variability within. So the total variability, it is the sum of between samples variability and within samples variability. So let's understand this concept through a picture. So let's suppose this is one sample, and this vertical dotted line is the mean value of this sample, and this bell curve shows the frequency distribution of this sample. Then we have sample number 2 and sample number 3. So these are their frequencies and these are the values. So what you can see here is that the mean value of sample number 1 is around 3, the mean value of sample number 2 is around 8, and the mean value of sample number 3 is around 13. So we have 3 samples, and their frequency distributions are smooth, they follow a smooth distribution curve, and their mean values are different. Now this is a within sample variance, right? So each of these samples have got their own variance value, which is the individual variance of each sample, right? And what is this within variance? This is the variability of individual observations within a sample around the mean value of that sample, right? As you can see that the sample number 1, the mean value is almost 3, it is around 3. So the variances, they are around 3, they are plus minus 3 mean value. And then for the sample number 2, the mean value is around 8, and we can see that variances, they are plus minus 8. And then for the sample number 3, on which the mean value is close to 13, and we can see that their variances, they are plus minus 13. So these are within sample variances. Then we have the between samples variance. So this is the variance which is found between different samples, right? This is the variance which is present between different samples. And why this variance is present? This variance is present because of the differences in their mean values. And here I have another picture for understanding the concept of variability between or variability within, right? So these are the three samples, and their frequencies, they are shown in the form of a column, and these dotted lines, they are their mean values, and these are what? These are the variances, right? These are the within variances, which are individual variances of each of these samples, right? So this is within sample variance. And then we have the between samples variance, which is the variance between the samples, and this variance is because of the different mean values of the samples, right? So the source of this between samples variability is because of the difference between the mean values of the individual samples. Now, when we have seen that what is meant by the between samples variance or within samples variance, now we can see the comparison of between variance and within variance, right? So, and this is the basic point, and this is the basic question that we were trying to address, that how the analysis of variance can be used for the comparison of mean values. And as we have seen that in an experiment, in an experimental design, there are two sources of variation, right? The between samples variability or the between samples variance, and within samples variance or within samples variability. And the total variability is the sum of between samples variance and within samples variance. So now let's see that how this comparison of the variances can be used for the analysis of comparison of the mean values, right? Which is the basic concept of ANOVA. So when we compare between variance with within variance, we have two situations here. So the first situation is that between variance is equal to within variance. And the second situation is between variance is not equal to within variance, right? So we have these two possible situations, whether between variance is equal to the within variance or whether between variance is not equal to within variance, right? So let's talk about the first situation, when we have the between variance equal to within variance. And this indicates that populations are with similar variances and similar means. So if we have a situation in which the between samples variance is equal to within samples variance, then in that case we can say that these populations, these three or more than three populations, they have similar variances and they have similar mean values because their between variance and within variance is similar. And then we have the second situation. So in the second situation, again, we can have two possibilities, whether the between variance is less than within variance, or the other situation is that between variance is greater than within variance. Let's see the first situation. If the between variance is less than within variance, then we conclude that these are the populations with similar variances and similar means, right? So if the between variance is less than within variance, it means that the population means are similar and population variances are similar. The second situation is when we have the between variance which is greater than within variance. So what is the situation in that case? It means that the populations, they have different means and or different variances, right? So we can have three situations here, that whether the populations, they have different variances, or the populations, they have different mean values, or the third situation is that the mean values as well as the variances of the populations are different. So if the between variance is greater than within variance, then it is because of one of these three possibilities, right? That whether the population means are different, or the population variances are different, or both are different. Now remember the assumption of ANOVA, or the requirement of ANOVA. The requirement of ANOVA is that we compare those populations which have equal variances. So if we assume that variances of the populations are equal, then this difference is because of the differences in their mean values, right? So let's do it again, that we are talking about the unequal between variance and within variance, right? And in that case, we are talking about the possibility where the between variance is greater than within variance. So if during the analysis of variance we find that our between variance is greater than within variance, then it could be due to 3 of the possible reasons. The first possible reason is that the populations have different mean values. The second reason is, or the second possible reason is, that the populations, they have different variances. And the third possible reason is that the means as well as variances of the populations, they are different. But when we proceed with the ANOVA, we make sure that variances are similar. So if we assume that variances are equal, then we are left with only one possibility, and that possibility is that the mean values of the populations are different, right? So this is how we can use the comparison of the variances, or the analysis of variances, for the comparison of mean values, right? That if the between samples variance is equal to within samples variance, then the populations, they have got similar variances as well as similar means. But if the between variance is less than the within variance, then we have the same situation, that populations, they have similar variances and similar means. But if the between variance is greater than within variance, then this is possibly because of differences in their mean values. Especially if we assume that the population variances are equal, then this difference is because of differences in their mean values. So this is the basic concept of ANOVA. Now let's understand this concept again with the help of examples of pictures. So here we have 3 curves or 3 samples, right? And their between samples variances and within sample variances are shown here. So what do you see here? That is there any difference between the between samples variance or the within samples variance? The sample variances, they are similar, and the between samples variance and the within sample variance, they also seem to be similar. So between samples variability is equal to within samples variability in this case. So what we can say here is that these are the populations with similar variances and similar means, right? And as you can see that these values, they are very close to each other, their mean values are very close to each other. And also there are many observations that overlap between the 3 samples, right? So in this case, if the between samples variance is equal to within samples variance, then we can say that the populations, they also have got similar mean values, or the difference between the mean values is non-significant. So we have another situation. This is sample number 1, this is sample number 2, and this is sample number 3. So what do you see here? That what is within samples variance and what is between samples variance? So which one is smaller and which one is greater, or they both are same? So we see that the between samples variance is less as compared to within samples variance, right? So we have to conclude that populations, they have similar variances and similar mean values. And as you can see through the picture as well, that their frequency curves, they overlap each other, right? So their frequencies, they overlap. It means that they have got similar variances and similar mean values. Now we have another situation, and in this case you can see that the between samples variability is greater than within samples variability, right? The individual variances of the samples are similar, but their within variance is less than between samples variance. So in this case, what we can conclude is that these are the populations with similar variances but different mean values, right? So this is the situation that we were talking about, that if the between samples variability is greater than within samples variability, then this is possible because of either the difference in the mean values or the difference in the variances or differences in both. But in this case, we can see that the variances of the individual variances of the samples are similar. So we are assuming that their variances are similar. Then this difference is because of the differences in their mean values. And that we can see here as well, that none of the curves, they overlap each other, right? So there are no similar observations found in any of these samples. So these samples, they are very much different from each other, and their mean values are also very much different from each other. And that is why this range or this interval of the between samples variability is much greater. So in this case, we can say that these are the populations with similar variances but different mean values. So this is how we can use the analysis of variance for the comparison of mean values, right? Now here we have another situation, and in this case also the between samples variability is greater than within samples variability. But in this case, the population variances are not similar. So is the difference between means significant? We are not sure, because the sample variances, they do not look similar, and unless we do the statistical calculation and we find out that this difference between the population means is non-significant, we cannot say that the differences in the means are significant as well, right? So similarly here we have the between samples variance, which is greater, and in this case the sample sizes are also different. The sample sizes are different and their variances are also different. So again, we are not sure because the sample variances, they do not look similar to each other. And we have a situation here, and here also the between samples variability is greater than within samples variability. Two of the samples, they are pretty close to each other, but the third sample is different. So in this case, is this difference significant? Again, we are not sure unless we calculate statistically that whether this difference in the variances is significant or no. Right? So this is how we can use the analysis of variance for the comparison of mean values.